Today we're going to walk through Packet Tracer 465. And at the front of the Packet Tracer, there's an address table which has information about the devices, their IP addresses if they have them, and what interfaces on the device on the left connects to the far end, the other end of the connection, which is going to be the column on the right. And the purpose of this packet tracer is just to practice selecting the appropriate cables when you're connecting devices. But don't worry if you don't know a lot of this stuff yet, because by the end of the course, a lot of this will be second nature. Just to walk through it, we'll start with part 1, which says connect to the cloud. Connect the cloud here, which is just an abstract representation of the internet, to router 0. And it says at the bottom left, click the orange lightning icon to open available connections. So our available connections are listed here. Choose the correct cable to connect router 0, fast Ethernet 0/0 to cloud Ethernet 6. Cloud is a type of switch. So what they're saying is there's actually a lot of devices represented by this cloud, but the edge device that actually connects this local area network to the cloud is a switch. ETH6 is the interface type on this cloud switch. When we connect a switch to a router, the lesson that we will or did cover on crossover and straight through copper cables is that the basic rule is if two devices are different types, use a straight through cable. And if two devices are similar, use a crossover cable. So they give you the answer for this one. A switch and a router are different types of devices. So a copper straight through, so you just click on the solid black line, which is the copper straight through cable. And they want us to put that on fast F0/0, which is short for fast Ethernet 0/0. And then click on the cloud, and you can see the matching indicator for RJ45. Even if they didn't tell you, you can see Ethernet 6 would be the matching type of connection. Another thing I want to tell you too is within Packet Tracer, there are things you can do to increase your benefit of your learning experience using Packet Tracer, which is instead of just seeing an abstract cylinder here to represent a router, it's so much better to know what it looks like in real life. So if you click on a device and you look at the physical tab, you can actually see what the device looks like. There's a zoom in feature. Routers and switches often have the same form factor, which is this rectangular shape. And this is the back view of what the device would actually look like, which if it was mounted in a rack, the back would be facing you and you would be looking at what is actually present in a router. This router is the Cisco 1841 is the model. So there's a power cord for the connection, there's a power switch, and then it's going to have slots in. That it's like when you're shopping for a car and you pick different features. With a lot of routers, they're modular to where you can pick out different modules to plug into them based on what you need. And here's a list of all the different modules or module covers that you could get with this particular router and customize it. Now it comes with some fast Ethernet interfaces on it, abbreviated to FE. We connected the cable to fast Ethernet 0/0. These are RJ45. There's also a console jack and an auxiliary jack for out-of-band management. And this slot is not being used, so it's got a cover on it. Another slot here is a serial interface. It's called a WIC2T. And if you go over to the WIC2T item over here and click on it, it'll give you a description of what that device does, so that it's got 2 serial ports for WAN interfaces. So as you go through these devices, if you want more than just an abstract concept of what you're doing or a clue maybe of what kind of cable to use, a lot of times you can get that by looking at the descriptor of what you're looking at. Those 2 interfaces are successfully connected and up as indicated by the 2 green triangles. So the next thing it wants us to do is to connect the cloud switch to the cable modem. And it says choose the correct cable to connect cloud coax 7 to cable modem port 0. They give us a clue right there of what kind of cable to use. Also, if you have cable in your house, you already have seen the coax cable that terminates the connection in your house. So the correct cable, it's clearly a coax cable, which is this blue one here. So we just go to coax 7 on the cloud. And again, there's that icon that is also a clue that it's like a bayonet connector on a coax, what it looks like. If you click on that, click on the cable modem. And again, you don't even have to really know what port number because it's the only one that has that matching connector icon on it. So those two green triangles tell us that that connection is up. Now it wants us to connect router 0 to router 1. A clue of what kind of cable we're going to use. We already looked at and saw that router 0 had a serial module in it. And then here it tells us the first 3 letters of the interface are SER. So there's another clue. This is going to be a serial cable. So it wants us to connect router 0, serial 000 to router 1, serial 0/0. And use one of the available serial cables. So down here, we've got serial DCE type and serial DTE type. DCE stands for data communications equipment, which would be something that would be used for communication, whereas DTE stands for data terminal equipment. You know, if you think, well, is a router more of a communications equipment or terminal equipment? It'd be communications equipment. You want to take the DCE serial cable and connect it to serial 0/0/0 on this end. And then router 1, it says serial 0/0. And the icon for that is showing more of the serial shape versus the RJ45 shape. And you notice that one has that extra 0 on it. And that's because they're two different kind of routers. This is a 2621XM model. The serial card that it's using is in module number 0. That's the first 0. And then it's the first interface, because they start numbering with 0. The first interface on module 0 is 0. So that's where the 0/0 comes from. Okay, so we've got our 2 green triangles showing that that's good. And you might notice here in the lower right-hand corner of your instructions window, that percentage is starting to increase. Keep an eye on that, because when it gets to 100%, you know that you haven't made any mistakes. Let's do the next one. Connect router 0 to NetAcad.pka, which is a server. It says choose the correct cable to connect router 0, fast Ethernet 0 on the server. Now here it tells us that routers and computers traditionally use the same wires to transmit, wires 1 and 2. Because they use the same wires on that kind of cable, 1 and 2 to transmit, 3 and 6 to receive, even though they're different types of devices, they're actually considered, for the purposes of crossover or straight through, they're actually considered the same. This means that the correct cable to choose is going to consist of these crossed at the 2 ends so that they can both transmit and receive at the same time. And it says, although many NICs can now auto-sense, called auto MDIX, and adjust for that, if they do use a straight through cable, it says router 0 and NetAcad PKA do not have the ability to do that. Let's choose the crossover cable, router 0 F0/1, which again is short for fast Ethernet. And then on the NetAcad, there's only one Ethernet interface. And that comes up right away. Now it wants us to connect router 0 to the configuration terminal. This is one of those console connections. This is not a network connection. This is the correct cable that we would use to connect to the out-of-band management, the console cable. What we're going to do is go down here and choose a console cable, the light blue one. There's the RS-232 that it said. And then this, of course, is going to be the console. This configuration terminal will be a terminal emulator for configuring the console. This time we have black indicators that everything is good. It is correct. So for the remaining devices, we're going to connect router 1 to the switch, which is this layer 2 switch here. Let's have a look at the back of this router again. They have a fast Ethernet module, which they have installed in this. This is a 2621. Notice this looks different. This isn't the same type of connector that are on the 0 module. Fast Ethernet 0/1 and 0/0 would use copper, basically, RJ45 connections. But we're not using 0/0 or 0/1. We're using 1/0. So that means we're over here on, this is module 1. And there's only this one interface on it. So that is module 1, interface 0. There's a clue that you could get here. This is an NM1FEFX listed right here. This is the module that's actually plugged in. And if you read the description, it says this is a fast Ethernet interface for use with fiber media. The reason that it has those 2 little circles there is because on a fiber optic cable, it's a pair. Fiber optic cables are a pair at each end because you have to have one for transmit and one for receive. Each end is going to plug into a connector for it to connect to. So we know that this is going to be a fiber optic cable. Now this one here I just showed you is yellow, meaning it's a single mode type. But in actuality, if these were local, it would probably be an orange multi-mode fiber cable. We go to the fiber, which is kind of orangish, and we don't need to know the number because all we have to do is look for that matching visual indicator that's similar to the one on the router, that this is fiber optic. And there will be a similar one, just one on the switch side. It'll take a minute for that. It's going to be amber at first while it's connecting. So while we wait for that to come up, we're going to connect the cable modem to the wireless router. The cable modem port 1 is going to connect to the wireless router internet port. This would be just similar devices, and they are connecting port 1 on the cable modem. So let's try a copper straight through and see if that works. Port 1, the connector looks right. I think we're on the right track. On the wireless router, it says internet port. Yes, so this was a straight through cable. This connection is the wireless router's upstream uplink to get to the internet through the cable modem. Next, we're going to connect the wireless router to the family PC, choosing the correct cable for this connector. Now, it could be a little confusing because when we connected this router to this computer, we used a crossover because we said that for network purposes, they're considered similar devices. Therefore, use a crossover. This connection of this router to this PC is going to be different. If you look at the image itself, this wireless router, this is the internet port that we just used to connect to the cable modem for the uplink to the internet. But what this is sort of a combination of a switch and a router, which a lot of the small wireless routers often do have a built-in layer 2 switch so that people don't have to buy a separate switch if they just have a small footprint for their network. So this is going to be similar to connecting to a PC to a port on a layer 2 switch, which is where you would normally use a straight through copper cable because it's not a routing interface that we're connecting to. So we're going to do the straight through cable for this connection. That will go on the fast Ethernet RJ45 connection on the family PC. And then it says use the first of the 4 Ethernet switch ports. The light is amber while it's going through auto negotiation. That should turn green once it's correct. And we also have a visual indicator down here. It says we're 100% completed with the tasks that involve cabling that are being graded within Packet Tracer. I want to change the subject for a minute and explain something that you might see on the module 4 through 7 exam, where it might give you a packet tracer scenario, like on a PC in a packet tracer scenario. If you're told to open up a command line and find out what the Ethernet address and the IP address of the PC is, by command line, they mean go to the desktop and choose the command prompt. They should say command prompt, but if they don't, if they say go to the command line of the router or switch, they'll say so. But if they say go to the command line of PC, then open the command prompt here and do the command ipconfig /all It's a multi-screen output, but you're not going to need any more than just the very top part. Your physical address, this is the MAC address. This is the burned in address from the factory that would be in a switch MAC table if this is connected to a switch when the switch builds its MAC table. So this is the 12 hex value MAC address of the PC. So record that for reference later. And then this is the IP4 address of the piece of this particular PC, which is 192.168.1.100. So what would happen is if a switch is connected to some PCs and those PCs do a ping or send some kind of network data, what you would do if you were on the switch then would be the command is show MAC, and then you can do a question mark, and you want the show MAC address table. So it'd be like MAC dash would be the shortest way to type that. That is the command on a switch to look at the MAC table on the switch or the CAM table. If a switch is going to receive like traffic going through that switch, it's not going to record the IP address because this is a layer 2 device and IP addresses are at layer 3. So it's going to record by MAC address and then what port that particular MAC address device is connected to on the switch. So just a couple things to make note of that you might need to know when you're going through that exam. Back to our packet tracer, we're going to do part 4, which is verify the connections. So to test the connection from the family PC, which is this guy, to the NetAcad server over here, that's going to test whether all the network connections are up and established and if routing is working. So to do that, you go to the desktop, the command prompt, and then you can just type in ping netacad.pka. So this isn't going to happen right away. First, it has to do something called ARP to get the IP address that's associated with that domain name, and then it's got to get the MAC address associated with that IP address. So don't worry if it sits there and blinks at you for a while. Once it does successfully find and ping that remote device, because we have routing going on, there's routers involved because it's on a different network. This device here is on network 192.168 something, and that one's on network 10. But it has now remembered in memory who netacad.pka is. So if you were to do another ping, it would start right away because it's remembering. The next thing it wants us to do is to open the web browser on the family PC. So just use this X here to close the command prompt and then increase the view here, web browser, and then it'll tell you type in that URL. There is a web page that came up and it does show that that is working. The next thing it wants us to do is to ping the switch from the home PC. And by the way, just like any other end device like a PC, a switch has to have an IP address. Even if it's a layer 2 switch, it has to have at least one IP address so that it can be routed to for management. Open the home PC and ping the switch IP address. According to our table, it is 172.16.0.2. So that's yet another network. So we have routing involved once again. So we're on the 192.168.1 network. And our packets will have to be routed for this ping to work. So ping 172.16.0.2. Again, first couple aren't going to go because it's busy ARPing, and you're going to learn all about that later. But don't worry, it's going to start. There we go. So we were successful. Again, it's got that information in memory now. So that ping will work right away the next time you try it. Then it says to open router 0 from the configuration terminal. That means to go here. And if you're asked to do this like on an exam packet tracer, you always go to the desktop and use the terminal program, which in this case is a terminal emulator. Just accept the default terminal configuration values. It wants us to do a show IP interface brief. That'll be a command that you'll be using a lot to get the status of the interfaces as well as their IP addresses. You can shorten that to show IP int BR. Our interface statuses are, every interface on a router will have a different network because routers separate networks. That's what they do. That's why every interface is going to have a different network identifier, because the router is routing between all these three networks and any others that it learns about later. So they're all showing as up, the ones that are in use. The ones that are not in use are going to show as administratively disabled or down. This is a virtual interface that's not in use either, so it's administratively down. The next thing it wants us to do, going into part 5, this is where the document's going to want some answers. So it says to click the physical workspace tab or press Shift P and Shift L to toggle between them. And then it says, click the home city icon right here. Then it says to click the cloud icon. And again, here we have that real world view of the equipment. We're looking at the cloud itself, which is represented by this entryway to the cloud. This is a switch that has a position in the rack. There's a power cable connecting it to the power distribution device up above it. The question it wants us to answer is, how many wires are connected to the switch in the blue rack here? And that does not include the power cable. They're wanting to know about network connections. Remember our coax connection that's connecting the cable modem? Then we have the one green Ethernet. And if you hover over it, it'll actually tell you what the endpoints are and what type it is, copper straight through. The answer to that would be 2. There are 2 cables connected. Switch. Now it wants us to go back to home city. This little curvy arrow here is how you go back. Then it wants us to examine the primary network over here. I'm still zoomed in. It wants us to hold the mouse pointer over the various cables just to get that information. As you can see, the serial cable has a different appearance than the others. It's a completely different type of connector. And you've got your green lights indicating that these are active. Down below the router in the rack here is the NetAcad.pka server that it's connected to. And you can see if you hover over that cable that this is a copper crossover cable. The next question is, what is located on the table to the right of the blue rack? So we have to zoom out to see that. So this is the zoom out, and we can slide down, zoom back in a little bit. There's that PC that is the configuration terminal. The configuration terminal PC is located on the table to the right of the blue rack. Now we're going to click back to go back to home city. We're going to examine the secondary network. The secondary network is router 1. We also have that layer 2 switch we saw router 1 connected to. As you can see, the back of a switch often looks a lot different than the back of a router, because you're typically going to see the back of a switch populated with a lot of copper Ethernet type of ports. Why are there 2 orange cables connected to each device? We talked about that, right? When we looked at this example of a fiber optic cable, we have to have 2 cables connected to each device because of the fiber cables, as you can see here, actually being a pair in pairs. You've got to have one for transmit and the other for receive. And finally, go back to the home network. This looks believable for a home network. A couple desks or a couple tables, some PCs. Here's a wired PC, the family PC, which I believe is wired to that built-in switch on the Wi-Fi router. Then we've got a wireless connection for home PC. You've got the cable modem, the coax connection on the cable modem, and then there's the copper connection. There's a network printer, and then there's our wireless router, which is also using the built-in switch to provide a layer 2 switch for one of the PCs. So the question is, why is there no rack to hold the equipment? For the most part, home networks just simply don't usually have racks because they don't need them, and it's because it's a small network just for home use. So something to that effect is fine. So that brings us to the end of our assignment. And then you look down here, you see the completion is 100%. If it's not, just go to check results, assessment items, and look for a red X and narrow it down, and then go back and try to fix it and then see if the percentage updates. Then just hit close to get out of that. So that is it for Packet Tracer 465.